Alrighty. Hi, everyone. Welcome. Thank you for choosing to spend your time with us. Today's webinar will cover post-quantum algorithms in cURL, presented by wolfSSL Senior Software Developer Anthony Hu. My name is Ashley Barker, and I'll be moderating the webinar. All attendees will be in listen-only mode. If you have any questions, please use the Q&A box. After the presentation, Anthony will answer any questions you might have. As always, all of our webinars are recorded and made available on our YouTube channel. If you'd like to stay updated with all the latest from wolfSSL, feel free to follow us on Twitter, connect with us on LinkedIn, and subscribe to our YouTube channel. Feel free to reach out to us via email at facts@wolfssl.com if you have any further questions. Before we dive into the technical presentation, I'd like to provide a brief overview of wolfSSL. Today, wolfSSL secures over 2 billion connections. We have more than 1,000 OEM customers and dozens of resellers. wolfSSL consists of over 50 dedicated employees, primarily engineers. This progress is, of course, supported by a strong partner network that we're proud of. Since the beginning, our engineering team has developed several embedded security products, including wolfcrypt with DO178 support, FIPS certification and a FIPS-ready offering, MQTT up to the V5 specification, SSH v2, TPM 2.0, a secure bootloader known as wolfboot, Java wrappers, and JSSE support, and commercial support for cURL, and our newest product offering, wolfHSM. These offerings are accompanied by thorough maintenance and support plans up to the 24/7 level. We also offer full service consulting. Now I'd like to turn it over to Anthony to talk about post-quantum algorithms in cURL.
Thank you, Ashley. Yeah, as Ashley said, my name is Anthony Hu. I've been working with wolfSSL for almost 3 years now. So my two main functions in wolfSSL are as a post-quantum subject matter expert in terms of protocols and how they fit in and integrate into the protocols. And as well, some of you, if you use our technical support line, you'll recognize my name. I'm often answering support requests. Okay, so this is just a little bit of an intro slide, kind of talking about what we do here at wolfSSL. We're an open source company, so everything that I'm about to show you is all open sourced. So you can download all the source code, follow all the build steps that I outline here to reproduce what I'm about to show you. At the very bottom of here, it's just a list of partners that also that we like to talk about, and they're great because they make hardware platforms that we run on, and our competition just can't get on some of these platforms because they're like microcontrollers and bare metal systems, and we support all of that. Whereas our competitors struggle with those kinds of constraints.
Hi, Anthony. I'm sorry to bother you. We don't see the screen share, so if you could share the screen, would be great.
Oh, what is it that you do see?
I don't see your name. That's it. Yeah, I only see your name.
You only see my name. Okay, let me see
Yeah.
if I can stop the share. I apologize. I didn't realize that I was not sharing. What moment?
I was
Share.
able to see it. I'm not sure if that was like just me though. Maybe just try resharing it again.
Yeah. Desktop 2. Oh, here we go. Let's try this one. Share. Okay, can you guys see that?
Yes.
Yes.
Okay. Now I just switched slides. That's the slide I was talking about with regards to our partners. And it's probably cut off at the bottom. I apologize for that. Moving on to the next slide. So, there's no agenda slide. Okay. So yeah, before we actually get into the actual algorithms, Is this the slide? Yeah, that's right. I'd like to talk a bit about the motivation behind post-quantum algorithms and why we're doing all this work with regards to post-quantum. And most people think that the motivation is the impending presence of a cryptographically relevant quantum computer, and that is true. They're coming, and when a cryptographically relevant quantum computer comes, we're going to be in trouble. But there's a bit of a kind of backstory to this. Uh, the problem with saying that the cryptographically relevant quantum computer is coming is that nobody actually knows when. And so we all backpedal and say, well, then how do we prioritize this? What's going on? How do we put this into our roadmap? And so what's happened is instead of thinking of that of the dangers of quantum computers as a catalyst for motivating us towards these post-quantum algorithms, what's really motivating us is the coming of the new standards and new requirements from the government. So what you're looking at is a CNSA 2.0 timeline that was published by the National Security Agency, the NSA of the United States government. And so what you're looking at is that for web browsers, servers, and cloud services, by 2024, you should have already been adding these algorithms in as an option. So that's this year. That's right now. And this isn't for products like wolfSSL. This is end user products that the NSA expects to buy. And so if you look at it, they give you 1 year for experimentation on this blue line right here. And then in 2025, they're expecting that post-quantum algorithms are the defaults, right? So what does that mean? That means in 6 months, the products that they expect to buy are using post-quantum algorithms by default, not something that you turn on optionally, not something that is, that is off by default, and then you change your configuration, you turn it on. No, out of the box, these are the algorithms that should be running. So that's a really aggressive schedule. And if you want to sell to the U.S. government, if you want to sell to the NSA, this is a requirement that you have to meet. So these are our motivations. Let's talk about how the demo is actually going to run. Before the demo starts, we're going to be doing some preparation. We're going to be having a certificate chain, and that certificate chain is going to be a simple, very, very simple chain. There's going to be a root CA certificate, and that's going to sign a server certificate. The server will be given the server certificate as well as the private key that's associated with the public key inside that server certificate. The root CA will then be given to the client side, which is cURL, and cURL will specifically point to that CA certificate. These certificates are going to be generated using, at the very bottom, libOQS, and then the OQS fork of libcrypto, which is OpenSSL, and then right, which is OpenSSL. So then the application that is controlling libcrypto would be, of course, the OpenSSL application. And so that's the preparation, which I'm not actually going to show you, but this is the actual demo architecture. And so we're looking at, how does the connection look? So on the server side, again, it's going to be libOQS on the very bottom, wolfSSL, which will do the protocol, the TLS 1.3 protocol. And on the very top, the web server software will be Lighty, which is, well, it looks like it's spelled light HTTPD, but it's generally speaking, it's pronounced Lighty. And for the key exchange, we'll be using Kyber and the Kyber Chem. And for authentication and certificates, we'll be using Lithium. So let's talk about getting the code. Right, okay. So for libocus, you just, all of this stuff is available online. So these are just links to the various GitHub repos where you can download all the source code. Everything's just git cloned out of there. For the OQS OpenSSL, we use a special snapshot. So instead of getting it from using git clone, you can just download that link and then just unarchive it. Excuse me, I just finished lunch and a little bit got a little bit of a bubble in my throat there. And so for the various versions, we don't necessarily pick the newest versions of everything, because we don't want we do what's kind of convenient for you and what's convenient for us and what's available. So for example, for libocus, we're sticking with the 0.8.0 version. The git tag there. It's very convenient. For the OpenSSL fork, notably, we're using the 1.1.1 stable snapshot for that. It's fairly old, but it works and it's good. And again, if we were to go with something newer, we would have to go with something that uses that's with OpenSSL 3. So the 3.x.y branches of releases. And that would mean then that you would have to get a provider, and it would be a bit a lift. We're keeping it simple here by just using the OpenSSL 1.1.1 stable branch. For wolfSSL, we are going with the most recent version, which is version 5.7.0. This was only released just a few months ago. There will also need to be a patch on top of it. Just because the way we were using Lighty was originally with an older version and it didn't handle certain things properly. So, we weren't handling certain things properly. Don't worry, we'll get a patch in the next slide just so you understand what's going on. For cURL, we're using the latest, which is 8.8.0. Our OSP repo holds a script which helps you generate the certificate chain. And so we're using that particular Git hash because we don't actually make versions or releases of our OSP repo. And for Lighty, we're using the most recent release of Lighty as of today, June 26, 2024, which is 1.4.76. Okay, so let's talk about that patch that I was mentioning. And that's here. I think you can see the whole thing. Yeah, okay. And the patch is quite simple. We were doing something special in the case of if you used a different API to load. So normally you would load in the private key as a PKCS8 private key file. But we went down a different code path for if you specified the private key as a PKCS8 data buffer. And so the way that modern Lighty wants to do it is specify it as a data buffer. And we had been kind of doing it internally. wolfSSL have been handling post-quantum private keys in an invalid manner. And so that would trigger an error. And so this patch kind of lets us go back to use the same method for the buffering, for the buffer version as the file, the same methods for the buffering method as the file method. Yeah. So let's talk about how to build some software. The first thing you do is you got to build OQS because that's at the bottom of everything. So, these are just really simple steps. You just do a git clone, you do the git checkout. We do build, and we specify not to use OpenSSL in the CMake build line, and that's just a convenience for us. We don't, because we have an OpenSSL compatibility layer. We don't want in other use cases, we might have turn on that compatibility layer. And so if you're using OpenSSL, that can get things really confusing. So generally speaking, we always build libOQS without OpenSSL and without it using OpenSSL. And we do a make install. Since we didn't tell it where to install, by default, it will all go to /user local lib and user local include. So the OSP repo is really simple. You just do a git clone of it, and you do a git checkout at this particular hash, git hash. There's nothing really special about this git hash. It's just that in order to make things reproducible for you, we supply the git hash so that it's so that you can do exactly what I've been doing. So the next step is to build the fork of OpenSSL. And again, the only reason we use this fork is to generate the certificates. Yeah, and this step there's nothing really special about it. We configure for no share just to make it simpler. When you configure with no share, everything gets the OpenSSL application gets compiled as a static binary, and so there's less possibility for weird mistakes and weird problems with regards to dynamically linking. Note that in this particular build step, you don't have to install OpenSSL. You can run it in place. So what you're doing after make all is copying that dilithium script that generates your dilithium certificate chain. And it doesn't just generate one chain, it generates five different certificate chains. Sorry, 3 different certificate chains. One is for dilithium at level 2, the other is level 3, and the other is level 5. And when I say level, I'm talking about parameter sets. So similar to ECC, they're the NIST curves, right? Like SecP 256R1, SecP 384R1, SecP 521R1. Those are 3 different kind of levels of ECC, you could think of them. And in that similar vein, we have different levels of dilithium. And so, oh, that's the wrong direction. So then we build wolfSSL. Anyone who's familiar with wolfSSL totally understands what's going on here. So we're patching with the patch that I'd shown you before. We're doing a configure, the make all, and then the sudo make install. Of note, on the configure line, we're enabling all the features that Lighty needs. We're enabling cURL, and we're enabling experimental things. And that experimental thing is the use of libOQS. If you don't have the -- enable experimental, then the usage of -- with libOQS will fail. And that's just to let you know and let you understand and to reinforce that libOQS is an experimental part of the wolfSSL system. And the reason being is that's all going to change. There should be no expectation of backwards compatibility as we move forward, and that's because it's as of yet unstandardized. For example, when Kyber gets standardized by NIST, it will be known as ML-Chem. And so the name Kyber will then be removed. The name Kyber will be removed and replaced with ML-Chem. So the next step then is to, of course, build cURL. cURL is a wolfSSL project. The maintainer of cURL, Daniel Stenberg, works with Wolf as a part of wolfSSL, and I'm on regular meetings with him, and it's really good to be able to have the maintainer of the project and bounce ideas off of him and kind of learn from his wisdom. So here again is nothing really special about this build setup. The only thing of note is -- with -wolfSSL. In the previous slide, we did a sudo make install, but we didn't specify where to install it. So of course, everything goes to /user local lib and /user local include by default. With curl, it'll be the same thing. When I do -- with -wolfSSL, I could have specified the install location, but by default, it's just going to look in /user local. So we do a make install, and of course, all of that goes to /user local. And finally, we get to the Lighty step. So we do a clone here. We go in, we check out the latest version, which is 1.4.76 as of today. And we do the autogen and configure step. Of note, we added -- without -zlib and -- without -pcre. And those are on by default, but when you do a fresh install of something like Ubuntu, they don't always have the developer versions of zlib and pcre. When I say developer versions, I mean they don't necessarily have the header files already installed in /user include. So just to make it more convenient for you for people trying to reproduce this, we don't bother adding a step to install those developer headers for zlib and pcre. Instead, we just say without those libraries. So we do a make all, and again a sudo make install. And now it's time to set up the certificates. And so if you remember, we had that script from our OSP repo that generated the dilithium, what is it called? The dilithium certificate chains. And so we copy all of those into the directory where we built Lighty. We also have to create an index.html file, which will be served up by the Lighty server. And it's just a text file that says, congratulations, you got Lighty working with wolfSSL. You got Lighty with wolfSSL to run. Sorry, I should have been reading what I wrote. And of course, this is the .conf file. So here, a couple things of note. We're using we're configuring it to use mod wolfSSL. We're using absolute paths everywhere that we can. If you remember earlier, we had a patch file. The patch file allows us to have two separate files specified, the PEM file and the privkey file. Without that patch, you don't actually need that patch. What you can do is concatenate the two, the certificate file and the key file and then specify that file as a PEM file, and then you won't need to do this. But because of that patch, it allows us to do this nicely. Specify two separate files, that is. So now it's demo time. So let me see if I can get a couple of terminals up here. And yeah, here we have our terminals. Let me see if I can move them into the center so you can actually see what's going on. Okay, so on the left side, we've already gotten Lighty running. So there's the command line for Lighty. And here's the command line for what? Oh shoot! I did a, okay. I'll admit it. I did a practice run, and just to make sure it already works. But we're gonna do it all over again. And here we go. This is it. As you can see, we we got it running and we're good to go. So it's a long command line. It's hard to read, hard to parse. Don't worry about that. I am going to go on and I'm going to move on to show you all the command lines that you saw. I'm going to show them here in an easier to read format. The -D allows me to run without going into a daemon. That is to say that I stay foregrounded. Someone raised their hand. I'm just going to check. Oh, you couldn't see the terminals? I apologize. Let me see if I can do it so that I can show the terminal. I'm going to stop sharing for a moment and see if I can share screen, desktop to share screen. Okay, Shizuka, can I ask you, can you see what I'm seeing, which is demo time?
Yes.
Okay, I'm going to show the terminals again. Can you see the terminals now?
Yes, I can see the terminal.
Oh, excellent. Okay, good. So it's kind of funny. Okay, so as you can see here, I'm going to highlight, there's a sudo / user local bin lite, and then the liteconf. And so it's already running. I didn't want you guys to kind of listen to me type in my my sudo password, so I already had it running in before I started this demo, this presentation. And now we're just going to run, you know, the curl command line. And as you can see, we were successful. We got the required message. Now I'm going to, this command line is really, really long and confusing. Don't worry, you don't have to memorize it. I'm going to go in and break it down step by step to talk about what I'm doing in that command line. So here we are, we're looking at what are we looking at? We're looking at the command for running lite, and the -D again, like I said, allows us to stay foregrounded. It's not going to go into the background, and that just makes it easier to handle. I can Control-C when I don't want it anymore. So this is the meat of the information that you're going to get when it comes to this demo. So we ran user local bin curl. One thing that's kind of ancillary, but not like tertiary to the demo, but is somewhat important, is the use of the ld_library_path. I set it to /user local lib. And the reason why is because most modern distros have curl already installed. And so if you run /user local bin curl without that LD library path setting, it's going to want to link with the library that came with the distro, the one that's usually it'll be the one in /user lib, not user local lib. So that's why in this particular case you want to use the LD library path. Now, when you're doing, so let's talk about what's going on in terms of the command line arguments here. I specify -- curves P521 Kyber level 5. So what's going on here? Why is there a P521 here? Well, what we're specifying here is a hybrid key exchange. So you're doing Kyber at level 5 and ECC hybridized on the curve of 521, P521. So why is that important? Because in our migration, when we talk to our customers, we want to say, hey, we've got you covered. You got to go to post-quantum cryptography. This is the thing of the future. But our customers are living in the here and now. And one of their major concerns is compliance, right? They're thinking, wait, I can't give up on P521. I've got compliance requirements. I've got to stick with my FIPS 140-2 and 140-3 requirements. And so what this does, it allows for a transition time, right? So you can use be both in compliance with FIPS 140-2, 140-3, as well as the CNSA 2.0 compliance requirements, which is, it's very, very meaningful. It's something that's really important to, I think, everybody out there and all the stakeholders. The next thing we look at is the CA cert, and the CA cert is the one that we generated with that script. And the next thing we talk about is using TLS AES-256 GCM SHA-384. This is a TLS 1.3 cipher suite, and it is part of the TLS 1.3 standard. So there's nothing special about this particular cipher suite, except that it's got double it's using AES-256, when in most cases we would use AES-128. But the thing is that, we'll talk about that in the next, in the upcoming slide. The last parameter here is HTTPS://127.0.0.1. And why do we do that? Well, we were just connecting to the local server here. The local server is Lighty listening on 443, which is by default. Port 443. Okay, and so as I showed you before, you got Lighty with wolfSSL to run. So I think nothing went wrong. I think we're good to go. All right, so let's look at this at each security concept and how the quantum threat was averted. So for authentication, we used a lithium level 5, and that is actually mandated by the CNSA 2.0. There's also a level 2 and a level 3, but the CNSA 2.0 mandates level 5. And there we averted Shor's algorithm. For key establishment, we used the Kyber level 5 chem. And again, there's a level 1 and a level 3, but again, the CNSA 2.0 mandates that we use level 5, and that's Shor's algorithm that we averted again. Now for symmetric encryption, that's kind of interesting. We used AES-256. Like I said earlier, AES-128 is fine these days, but Grover's algorithm takes an AES key and it reduces the search space by half. So basically it somehow it takes the algorithm reduces the amount of time by half, approximately half, and this is an approximation. Again, I am not a cryptographer, so I'm kind of parroting off what I know from other people and people that are better than me, sorry, that are actual cryptography experts. And so what some people would say is AES-128 is still fine in the presence of a quantum computer. But if you want to maintain that security level of AES-128, then go to AES-256 because it doubles your space. It doubles your key space so that when you half it, you go back to the same power of AES-128. And that's an approximation. That's not a true doubling in half. So as a bonus here, we're doing key establishment with ECC P521 hybridized, right? So what's going on here is we're still, as I said earlier, maintaining our FIPS 140-3 compliance, which is really, really meaningful to your customers, especially today, right? You want to get them moving today. So just a bit of, as I said earlier, there's a level 1 and a level 3 for Kyber and level 2 and level 3 for dilithium. These are all just the post-quantum algorithms that we currently support. I haven't mentioned Falcon very much, and that's because NIST is holding off on standardization of Falcon until a little.
Oh, sorry, Anthony, I think you accidentally muted yourself.
Thank you. Sorry about that. Sphinx, I was mentioning that Falcon is, what is that called? Yeah, so Falcon is slated for standardization, but they're holding off a bit on it because of the use of floating point numbers in the algorithm, so it makes it more difficult. So they're trying to be very careful in the writing of their documentation for it. Sphinx is not appropriate for TLS, so we didn't really talk about that in this particular presentation. And LMS, HSS, and XMSSMT are not appropriate for TLS again, because these are stateful hash-based signature schemes, so we didn't talk about them. And so, yeah. So one thing that's really interesting is interop testing, and we have interop tested with the OQS project's OpenSSL fork, and our TLS 1.3 implementation does interop with their TLS 1.3 implementation. And that brings me to the end of this demo presentation. Yeah, does anyone have any questions? I'd be happy to answer. And before I forget, if you're feeling shy about asking questions, don't worry about it. You can email us at facts@wolfSSL.com. And when you do that, you can ask us your question or even request slides. And we would be happy to get these slides to you. Okay, Ashley, I'm going to hand it off to you to host the Q&A session.
Yeah, awesome. Thank you, Anthony. So it looks like we do have a few questions. The first one is, what are the hardware requirements for the stack for a minimal embedded system?
Oh, that's an interesting question. So this particular demo is not suited for an embedded system, as I've shown you right here. And the reason why is because I've been using, the configure and the autoconf tools, and so this is kind of a Linux specific run through. But something like a Raspberry Pi, this is perfectly fine. In terms of hardware requirements, if you want to go really small, I've actually got another video another webinar where we do this same kind of demo on an STM32. What is it? Let me see. I have the board right here. It's called Nucleo F446ZE. And we do a similar demo for that. That runs on a ARM Cortex M4 board. And so you can get all the way down to ESP32. We've got ESP32 demos where we do a Kyber key exchange there over TLS 1.3. So yeah, I mean, the hardware requirements are those minimal? I don't actually know. I mean, could we go all the way down to a PIC32? Maybe, but I just haven't really tried that. So I hope that answers your question. I don't think I got down to the minimal, but I kind of let you know the minimal of what I've tried.
Awesome, thank you. And the second question is there a bare metal equivalent similar to the cURL client available that could be used in microcontrollers for IoT applications?
That's a really good question. I'm really good you asked that. I'm really glad you asked that. And the reason why is because cURL has a sister project called TinyCurl. TinyCurl is made to run on microcontrollers. So things like what was it? Like STM boards, the NXP, a whole series of NXP boards, Texas Instruments board. I've actually run TinyCurl on a Texas Instrument board, so for sure TinyCurl will work there. It works with FreeRTOS. It works with I think it works on bare metal. I think it can even go as far as just about any microcontroller environment. So yeah, curl is going to be TinyCurl is going to be definitely where you want to go with that. I hope that answers your question.
Perfect, thank you. We just got another question in as well. Says, what kind of performance impact can we expect when moving from current NIST recommended algorithms to post-quantum algorithms?
Right. So when you say current NIST recommended algorithms, I think what you're talking about are like ECDHE and ECDSA on the NIST curves. And the good news is that your performance isn't going to suffer. In fact, it's going to improve. When you look at Kyber, Kyber is, which will be known as MLChem, far and away exceeds the performance of ECC. So when you compare Kyber level 1 and SecP 256R1 ECDHE, the algorithm execution time gets cut in half. That is to say, Kyber literally takes half the time of ECDHE. The performance gains aren't so pronounced when you get to level 5 and comparing it with SecP 521, but it still does better than SecP 521. So that, in that sense, you're actually have nothing to worry about in terms of performance. Now, that said, there is a caveat there, and that's that the artifacts are going to be larger. So if your transmission medium is very small, or your transmission medium has very small packets, you might get fragmentation. If your transmission medium is very slow, that's going to affect your transmission time because you have more bytes to push through the pipe. So that's something that you're going to have to think about in terms of, it's not just performance you have to think about, it's the transmission time. I hope that answers your question.
Thank you very much. Looks like the last question we have right now is, do current CAAM processors generally support post-quantum algorithms directly, or do they need special implementation?
So CAAM, I'm not actually sure what a CAAM processor is, but if we're talking about, if we're talking about things that wolfSSL runs on, so we have our own implementation of Kyber, and I believe we have a pull request for our own implementation of dilithium. And when you run true to the nature of wolfSSL, those implementations run on any platform that wolfSSL supports. So if you've got a microcontroller and you build wolfSSL and you enable Kyber, it will run on that particular platform. Now, we do have optimizations for particular platforms, for example. We have optimizations for ARM, as well as x86, obviously. And so these optimizations are done in assembly. So to answer your question, will our code run on a CAAM processor? Well, if wolfSSL runs on CAAM, then yeah, it will run. Have we done the optimization for the assembly optimization for your particular processor that you're thinking of? I'm not sure yet. I don't really know. But if you give us an email and you email facts@wolfssl.com and you ask us, and you let us know that you have an interest in assembly optimizations for a particular algorithm on a particular platform, we'll get right on it for you, no problem. I hope that answers your question.
Wonderful. We do have another question coming in too. So it says, do you have a demo for post-quantum streaming protocols like RTSP for video streaming?
RTSP. I am not familiar with that protocol. What I will say is that if there is a library, an open source library that implements RTSP, and it has cryptographic hooks into other cryptographic implementations such as OpenSSL or Bounce Castle or whatever, it shouldn't be very hard at all for us to do an OSP. So OSP stands for Open Source Project integration and get post-quantum algorithms supported into that. I hope that answers your question. Whoever asked that, can you give another question where you specify what RTSP stands for?
Yeah, I'll let you know if that comes in. We just got another one. Says, as a business consumer, what post-quantum technologies should be looking for in a solution to secure data in transit and at rest? Or should I be looking for in a solution to secure data in transit and at rest?
So what you should be looking for today is a bootloader. Our bootloaders that support stateful hash-based signature schemes. Those are standardized, and there's no reason that anyone should be waiting for those. For the other things, you should be talking to your vendors, asking them questions. Things like, hey, what are your plans? What are you doing about post-quantum? Let them know that you are aware of the CNSA 2.0 guidance. Let them know that you are aware that these algorithms are going to be coming to FIPS 140-2 and FIPS 140-3 certification systems, and you plan to stay up to date with your FIPS certifications. So let the supplier know that they need to get on board and they need to figure out a plan that satisfies your confidence levels that they will stay up to date. And that's a great question, because I'll tell you right now, a lot of people are ducking their heads in the sand trying to think, well, post-quantum, yeah, that's years away. That's years away. And to some extent, it's true. The coming of the cryptographically relevant quantum computer is years away, but the standards are not. The standards are coming very, very, very quickly, as are the requirements. Ashley, next question.
Yeah, I sent in the chat a link to the RTSP that was sent in as well, and the person that sent it said real-time streaming protocol version 2.0, typical stack would be wrapped up in GStreamer. So I'm not sure if that helps at all.
GStreamer, is GStreamer, oh, sorry, I guess I'm going to get into a conversation with this person who's asking, is GStreamer, is any of this stuff wrapped on top of TLS, like TLS 1.3? If so, I mean, we could it would just be riding, like, for example, MQTT rides on top of TLS 1.3. So we brought post-quantum algorithms into MQTT simply by integrating them into TLS and then having our MQTT implementation talk to the TLS 1.3 implementation in wolfSSL. I'm hoping that's the same thing. I'm going to go look up this RFC that was mentioned on my own. Sorry, I don't know if this might be a time sinker, but sorry. We can look into this. Oh, wow, this is really complicated. Okay, this is a very, very complicated RFC specification. We're going up to 300 pages here, so I'm not going to be able to get a good grasp of this protocol within the next 15 seconds. So if the person who asked this question, if you could please send a message to facts@wolfSSL.com, which is on the screen right there, we would be really interested in knowing what your use case is and how we can help. I have a feeling this is something about video between one microcontroller and another, or within a single system, in which case you would be wanting to do something like TLS 1.3 or this RTSP protocol over some sort of internal bus. and wolfSSL supports that nicely. For example, we do TLS 1.3 on UART, SPI, as well as I2C. So, I mean, we could probably do this sort of thing there. And we use our, what is it called? Our IO callbacks facility to kind of abstract away all the hardware stuff, all the hardware specific we abstract all the hardware specific KPIs by using our IO callback system. So I think we could probably accommodate anything that you needed to do with this RTSP question. But I think a conversation with us would be in order. I can't answer these questions as part of a webinar. I just don't have the time to get the context into my mind. Sorry about that, but please do email us at facts@wolfSSL.com.
All right, that looks like we've answered all of the questions that we had sent into the Q&A. Thank you, Anthony, for hosting such an informative webinar, and thank you to everyone for joining. I'll email a copy of the webinar recording as well as the PDF slides. You can keep up with our upcoming events, meet our team in person, read our blog posts, and get the latest wolfSSL updates by following us on X, connecting with us on LinkedIn, and subscribing to our YouTube channel. If you have any other questions that were answered today, don't hesitate to shoot us an email at facts@wolfSSL.com. We're always happy to help. Thanks again, and we look forward to seeing you next week on July 10th for the partner webinar with ST Microelectronics Wolf Boot Security on the STM32H5 with PUKey. Great. Thank you, everyone. Have a good rest of your day.
Bye-bye now.